right, so we're going to be solving rational equations today. So it's just solving fraction problems. One thing that we've got to be careful of is today we do have to find our excluded values because we need to compare those to the answers that we get, because sometimes we may find an extraneous solution that is not usable because it makes a denominator equal to 0. So excluded values, we're going to have to find those today. And when do excluded values exist? When what's in the denominator? A variable, yeah, an x or whatever letter they're using there. So if there's a variable in the denominator, you know there's going to be excluded values. And how do we find those? Set that denominator equal to 0, and there we will find the excluded value. So let's just start with something easy. That. So how would we normally solve that? Well, you could. No. Cross multiply. It's proportion. It's a fraction equal to fraction. So you cross multiply. 8 times 6 is 48. 3 times 11 is 33. And then you would divide. If it's one fraction equal to one fraction, that's how you want to do it. And then reduce 48 and 33, 16 over 11. Are there any excluded values to that problem? No variable in the denominator, so there's not any excluded values to find out of that. Okay? We like it when it's easy, right? Well, you know it's going to get harder, but let's start with easy. So with this one, are there any excluded values? Yes, so we know we're going to have to find those. So our excluded values are going to be x plus 1 equals 0, which gives us an excluded value of -1, and then 4x plus 5. Yeah, -5 over 4. And you guys have gotten so much faster at solving those things. It's stinking impressive. Okay, so now it's one fraction equal to one fraction. So the quick way to solve it is cross multiply. Okay. Emma said that we could do a common denominator. That's true, but it takes more time to do that. So if it's one fraction equal to one fraction, this is the way that I would do it. It's more efficient. You end up doing a lot of the same things. So 9 times x plus 1 be 9x plus 9, right? And then the other side will be 12x plus 15. It doesn't matter which side you put that on, okay? You put the 12 plus 15x on the left side, that's fine. I don't care. It's the same. And then solve it. So -6 equals 3x. And x is -2. And that doesn't match one of our excluded values, so we're going to keep that answer. If it were to match one of our excluded values, we throw it out. Okay, so it's possible that we end up with some with no solution.
Okay, so what if you have, so you just don't have anything that's going to be excluded values and you have like one answer?
Yes, yeah. If you have one answer and it happens to be one of the excluded values, it would be a no solution. Yeah, that's can happen anyway. All right. Another one here. Okay. Will this one have excluded values? Yes. So we need to find those. And I'm setting 2x plus 5 equals 0. -5 over 2. -8 over 11. Good job. Okay, so those are our excluded values. And now it's one fraction equal to one fraction. So the quick way to do it, cross multiply. So 1 times 11x plus 8 is 11x plus 8. x times 2x plus 5. All right. So it has an x squared in it. So what's that mean? We can do factoring or quadratic formula, but in order to do one of those, we've got to get it equal to 0. Descending order and equal to 0. Good job. Go ahead and subtract 8 there. So I get 0 is equal to 2x squared minus 6x minus 8. GCF is 2. You didn't pull out the GCF. You'll get the same answers. So this would be x minus 4 and x plus 1. The 2 goes away because it doesn't have a variable. Those equal, so x equals 4 and negative 1. That doesn't match either of our excluded values, so we keep both of them. Not too bad right here so far. Yeah, you've done proportions before, so that's where it comes. Now, let's diverge from what you've done before into throwing that in there, yeah. Combining what we did yesterday with this stuff. So let's do 5 over x plus 7 over 4 equals negative 9 over x. All right, so here we don't have just one fraction equal to one fraction. We've got an addition of fractions with different denominators on the left side, and it's equal to another fraction on the other side. So in order to work this problem, we're going to have to do addition with fractions. So that means we have to find a what? Common denominator. So the LCD for this one will be what? 4x. And then to find our excluded values, we set the common denominator equal to 0. For all three. All three. Just happens to be that these two have the same one. We'll get to some that don't, but it's the common denominator for the entire problem, not just the left side. I'm glad you asked that because I didn't say. So common denominator for the entire problem is 4x. Set that equal to 0. Excluded value is 0. Easy. Okay. Now we need to fix every fraction so that it has the common denominator. So what's the common denominator? Or what do I do to the first one to fix it? Times 4 on top and bottom. Second one. Third one. Okay, so it's going to get us 20 over 4x plus 7x over 4x equals negative 36 over 4x. Once you get the denominators the same, then you create the numerator equation, which means you just look at this part. If the denominator is the same, then the top part is going to be where we find our answers. So we said 20 plus 7x equals negative 36. Just take the numerators, drop the denominators out. You don't need them anymore once you get them the same. And then solve. 7 and x is negative 8. That doesn't match our excluded value, so we keep it. And we get our answer there. Not too bad. Kind of nice when they have a couple of the fractions the same denominator. It makes it a little easier. Okay. Let's go to one that's a little tough. 1 minus 8x, or excuse me, 8 over x minus 5 equals 3 over x. Yeah, sure. Probably help you think about it a little bit. So Got three different fractions, addition and subtraction on one side. That's what makes us know to do a least common denominator. Yeah, there's no factoring that can happen. So x and x minus 5, you're just going to have the product of those two. And then, so your excluded values be x equals 0 and x equals 5, right? Kind of, we can do a lot of that in our head. We don't have to, show much work as far as that goes. Now, once you decide what the common denominator is, you got to fix every fraction so that you get all the denominators the same. So what does the first fraction need? All of it, yeah. So it needs x and x minus 5. Yeah. And then the second fraction needs x. The third fraction needs x minus 5. So multiply out the numerators there. So x squared minus 5x over x minus 5. So don't multiply out the denominators, but always multiply out the numerators. And then 3 times x is 3x minus 15. Once you've got the denominators the same and the numerators all multiplied out, set up your equation with just the numerators. You're going to see as you can get into this, there's a few steps you could skip, like rewriting this. Some of you may be able to skip that step, if you feel comfortable doing that. Now we got a funky looking problem. It's got an x squared in it, so what's that mean? All right, so we can get all our like terms together. So that's going to be x squared, -8, -5, and -3 would be the -16 until he said. Factoring would be a great option on this one because it works. 15, -16, -15, -1. Do either of those match our excluded values? No. How else could I have solved that besides factoring? Quadratic formula would have also got us the same solutions to that. So keep in mind all of those things that we've done with quadratics can come back there. All right. Number 6 is that. 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. So think about what we did yesterday and what your first thing, there's a difference of squares in there in the denominator. So that's going to tell us that that'll factor as x plus 3, x minus 3, which is kind of nice because look at the denominators of the other fractions. You don't need that much. Yeah, you just need 1x plus 3 and 1x minus 3. Because this one had the shared factor with these two fractions is x minus 3. The shared factor with these two is x plus 3. So each of the shared pieces in the denominator. Okay. And there's no, so the fraction that kind of has the biggest denominator, that's the one that kind of decides a lot of things. Okay. All right. Now, how do we fix those? Yeah, so, we got to find excluded values. Let's do that first. That's a plus or minus 3. All right, so then x plus 3 on the first one, x minus 3 on the third one. But what about the second one? Nothing needed. It's got everything, right? So 6x plus 18 And here's kind of where I start skipping steps. Like, I've done all the work up here to get the denominators the same, right? So I know my next step is just to look at the numerator equation. So that's all I'm going to write down. I'm going to say 6 times x and 6 times 3, 6x plus 18 equals 8x squared minus 4x squared plus 12x. Why is it plus 12x? Yeah, it's a negative in front there, so it's where the double negative turns positive. So, and I'm not worried about the denominators anymore because they're the same. So they're the next step, they go away anyway. So just go ahead and sweep them out of the way now. Okay. And that again, that minus sign is like you tie it with the 4x there. Tie it with that numerator. All right, simplify 4x squared, and then move. I'm gonna move the 6x and the 18. 4x squared plus 6x minus 18 is equal to 0. I'm getting it equal to 0 because it's got a variable with an exponent on it. Everybody's divisible by 2. That'll make my life easier if I'll just divide them. Get rid of it. 2x squared plus 3x minus 9. And then you could do quadratic formula. That would work. Go for it. I'm going to factor it. 6 negative 3. I can't take the shortcut, so I got to go 2x squared plus 6x minus 3x minus 9. And group those together. Plus 3, negative 3, x plus 3. And so you get two answers there. You get 2x minus 3 and x plus 3 as your factors. So as x equals to positive 3 over 2, and x equals negative 3. Yeah, that negative 3 is an excluded value, so it gets thrown away. Here we finally found one that they throwing stuff away. Yeah, that's why I like grading papers. No, it's not.
Grade my paper.
I get to do that a lot. Yeah, and it is more satisfying to mark it correct than it is to mark it incorrect. All right, one more. I don't even know what number it is. 7. Only 7 examples. Gosh. Solved. 7. Yeah, it's amazing. I taught you something that you need for next one. It's so amazing.
How are your kids?
They're great. She's good. Let's grab
It's always crazy. Mom is always crazy.
EOC this week or next week, and then she's got 2 different ones. And
She's I did.
out of the one and then she's her. They got mistletoe ball this week.
Have y'all ever argued over math class?
Not since college.
Who's right?
You can guess. All right. Now, what do we got to do to that? You got to factor everything before you can find that common denominator. So yeah, we got to find a common denominator. So this factors is 3 and x plus 3. 3 factors out of that one. Plus 6. Sorry.
The other one can't factor. Oh, wait, never mind.
Yeah. All right, so the second fraction factors pretty good way. So it goes back to that thing we did a while back where it's factored completely. You got to always look for all that stuff. So fun times, looking back on when times were good.
Is that not the least common denominator, the middle one?
Yeah, the middle one ends up being the least common denominator. Again, it goes back to that idea of the fraction that has the biggest denominator usually decides most of the stuff. Okay, so when you're looking at these problems, the one that's got the most stuff in the denominator is usually going to be the one that does the most work. Right? So least common denominator is going to be 3. And then there's a shared factor of x plus 3. And then we got the other stuff that ain't shared, which is the x plus 2. So that's our least common denominator. And it ain't going to be the same thing on the top because every fraction needs something different. So it's going to be different things on the top because not every fraction needs the whole thing, right? So here we're excluded values. We get those -3 and -2. And then let's go back in there and find out what each fraction needs. What does the first fraction need? An x plus 2. Second fraction's got everybody it needs, so no need to. Yeah, I would go ahead and multiply that out. We already know it's x squared plus 5x plus 6. So I'm just going to put that up top. Because I'm going to have to do that anyway. Remember, we're going to multiply out the numerators, but never the denominators. Always multiply out the numerators, though. So now that we've got the denominators the same, all I got to do is the numerator stuff. So 1 times x plus 2 is x plus 2 plus 1. 1 times x squared plus 5x plus 6. And so the left side, yeah, is x plus 3. And then we need to get it equal to 0. Subtract x, subtract 3. It'll be x squared plus 4x plus 3. And that'll factor as x plus 3 and x plus 1. And x equals -1 is the only answer we find that works. That we're going to get to keep. Woo, fun stuff. All right. Questions? Because of what we've done in the past, it makes it's basically the same thing. We've done enough equations in the past that it doesn't get, doesn't get above our heads there. So I think you're going to be okay.